The following illustrative use cases for artificially intelligent querying, AI instant setup and executing a new neural map for a digital twin, sandbox and virtual machine discussed here are excerpted from a confidential document titled AISC Artificially Intelligent Supply Chain, Use Cases. In this use case, this order is not in the system. I want to add it as it impacts the supply chain, impacts many modules starting with AI instant setup, big data storage, auto messaging, analysis and aggregation, and all predictive AI modules. It illustrates a good deal of the system. This journey begins with a user-friendly, natural language interface designed for seamless integration with your unique perspective. Multi-factor authentication ensures secure access to the system, while our core strength lies in interpreting any language command, be it text or voice, to drive AISC. Powered by ChatGPT-4's large language model, LLM, we offer cutting-edge capabilities. You can start experiencing the benefits of this transformative journey right away, whether you're placing your next order or uploading order/shipment data to optimize your entire supply chain. The natural language query process generates a query view within the sandbox and virtual machine. If additional processes, variables, or data are required, the natural language processor determines whether the query relates to an existing solution or a new need. If it is the latter, a manual process is initiated to create a new product and define its logistics supply chain properties. For a truly unique product, the user must provide specific identifying data such as SKU, size, weight, chemical restrictions, potential suppliers, and any other unique attributes via the AI startup screen. Here, the communication is centered on the user's perspective and is first distilled by the natural language processor. Much like a sandbox offers a safe, controlled space for children's play, our shared sandbox environment is designed for modifying, creating, and implementing diverse use cases. These use cases are crafted or integrated by development consultants who are experts in their respective fields. This innovative design enables us to swiftly address user needs, ensuring the system remains up-to-date and autonomous. By using a unified interface to deliver modules, developers and support teams can build use cases, safely test modules with real data, release a working version, create an automatic programming mode, which can be toggled on or off to implement changes. Virtual machine will manage space requirements during changes, implement safely on user machines. How we achieve rapid development with Sandbox and Virtual Machine. The development of this module harnesses several commercial APIs, including Kodi by Sourcegraph, Manage Engine for sandbox development, Python and MATLAB for analytics, and Dwolla or Stripe for secure payments. Additionally, we utilize Azure, AWS, and Google APIs for big data integration. A common interface begins with Query View, a streamlined interpretation of natural language commands, and incorporates several utility submodules: load, save, archive, display, print, run, send, approve, receive/implement, and auto. The auto, or autonomous, mode is always active and only deactivated if an error occurs during query processing. AI action modules, such as map, measure, demand, replan, warehouse, and inventory, are engaged in autonomous mode. One of the most challenging and intricate modules in supply chain management is the digital twin. Supply chain planning operates on three hierarchical levels: strategic, tactical, and operational. Operational planning focuses on the sequencing of orders within an existing supply chain. In AISC, the autonomous digital twin is specifically tailored for operations. A digital twin for the order fulfillment process can be simulated using discrete event simulation because AISC possesses precise knowledge of the network, the events in the order fulfillment process, and the state of system variables. For operations, our focus is throughput. The throughput of successive events in order processing is defined for four key variables: time, cost, distance, and mode of transportation. Order processing events provide accurate and current data for these variables, and their variability to conduct simulations. In a done deal scenario, AISC processes the query either autonomously or through further user interaction, as illustrated in the following example. When a user initiates a query like, "This order is not in the system, I want to add it as it impacts the supply chain," the system generates a query view labeled Add Order. The digital twin submodule is automatically loaded within Sandbox and VM, followed by the auto selection of the map function. If data is available from an external order processing system, the current neural network for a similar product is displayed. Essentially, the system inherits logistics supply chain properties such as time to deliver, distance, cost, delivery methods, and all participant nodes. An underlying aggregate/disaggregate algorithm determines similarity or dissimilarity, identifying whether something is completely new or similar. If you are in a shared network, properties for products and suppliers may be accessible, a clear benefit of sharing in supply chain partnerships. Each step is traceable, with a script recording the process and informing affected parties via an auto messaging agent. In auto messaging, the informed parties may accept or reject your request. If rejected, a manual process is initiated to create a new product and define its logistics supply chain properties. For a truly unique product, the user must provide identifying data such as SKU, quantity, size, weight, chemical restrictions, potential suppliers, and all other information that makes the product unique via the AI Startup screen. The system through Preprocessor DB will create usable input fields for further processing. Here the communication is from user point of view, first distilled by Preprocessor DB, creating acceptable DB fields and map to legally acceptable EDI purchase order. Preprocessor DB, data input fields and map equivalent fields are automated steps if order is being transmitted from an order processing system. Otherwise, AI user natural language input forces a creation of all the necessary fields for a new order and updates the neural network. This network autonomously adjusts logistics plans based on changes in near-term demand. AISC uses recurrent neural network for forecasting. After a new order injected or input, AISC updates throughput and based on demand adjustments replans routing, instructs warehouse and plans inventory.